Let's look at some examples of radical equations in part 2. Here's our first example. Recall that when you raise to the power of 1/2, that's the same thing as square root. So we could rewrite it as square root. Remember, the denominator's the root and the numerator's the power. Okay, so our steps are to isolate the radical. And step 1 is already done. The radical is all by itself on one side. So now we'll raise both sides to the power of the index and solve. Now we can use the square root method to solve this quadratic. And we get two solutions, plus or minus 4. But we have to check because we might have an extraneous solution. Let's insert 4 in for x and see what we get. So it looks like 4 is a solution. Let's try negative 4. Well, when we square negative 4, we also get 16, so we're going to get the same result. So in other words, both 4 and negative 4 are solutions to this equation. Let's look at another example. This one's a little more complicated. It has 2 radicals in it. So in order to solve an equation like this, we want to isolate the more complicated radical expression. So of the two, the 3x plus 7 is the more complicated of the two. So we want to get it by itself. So we'll subtract the square root of x plus 2 from both sides. Okay, now we just follow our steps. The radical is isolated. We're just concentrating on the square root of 3x plus 7 right now. Raise both sides to the power of the index. The 3x plus 7 comes out from under the radical, but now notice I've written it twice here so you can see what's going on. 1 minus the square root of x plus 2 squared just means written twice and then FOIL. So when we FOIL, we get this result. See if you can figure it out. Okay, let's simplify. So we had we had a negative square root of x plus 2 and another negative square root of x plus 2. In other words, we had 2 of those. And then the square root of x plus 2 squared was just x plus 2. So now let's simplify. We'll get the 2 and the 1 together for 3, bring the x around. And now we just have one radical in this equation, so we're going to start again with isolate the radical. Let's subtract 3, subtract x, so that we have the radical by itself. The negative 2 in front of it, it's multiplied by that. That's okay, you can leave that. That'll be fine. We don't have any other terms on the right-hand side. We just have the radical term. So now what do? Raise both sides to the power of the index. And what does that do? That 2x plus 4 is 2x plus 4 times 2x plus 4. FOIL it, right? Oops. So this is what we get. 4x squared plus 16x plus 16. On the right-hand side, the negative 2 squared is 4, and the square root of x plus 2 squared is just x plus 2. Now, distribute the 4 into those parentheses. 4x plus 8, and now it's a quadratic, so we just want to subtract 4x, subtract 8, so that we have 0 on one side. And then we want to factor this if we can. If we notice, all of the coefficients are multiples of 4. So this will be much easier to factor if we pull out that 4. And then we have x squared plus 3x plus 2, which factors to x plus 1, x plus 2. X plus 1 equals 0, so x is negative 1. X plus 2 equals 0. X is negative 2. Two possible solutions here, negative 1 and negative 2. Let's check. Plug in negative 1 in the original radical equation. And what do we see? We see that negative 1 does not work because 3 is not equal to 1. So negative 1 is an extraneous solution. It is not a solution to the original equation. Let's try negative 2. Looks like we've got one. 1 equals 1, this is true. So negative 2 is a solution to this radical equation.